Hello, my name is Rainan. I live in Kourou. That's in French Guiana in South America. From here, the European Space Agency launches rockets into space. I always go and watch. It's really spectacular. I also build rockets. I want to launch them as high as possible. This isn't a real rocket, but it's just as big. Rockets are like cargo ships. They carry satellites into space, and they fly to the space station to bring the astronauts fresh food. As many as 10 rockets lift off from here every year. But how do rockets work, and why can they get into space when mine can't? I have a unique chance to take a look at the launch sites in today's foolproof rockets. How does a rocket work? Imagine I'm a rocket on a skateboard. If I push myself off from a post, I move forward. A rocket doesn't have a post to push off from, but it still moves. To help me explain, I need Joel, the strongest fireman in all French Guiana. Back to the rocket. Joel and I both stand on the skateboard. What happens if I push off from Joel instead of a post? Then Joel and I both move. I go far, but Joel just moves a little. It doesn't matter who pushes, we both move. But check this out. I stand with Joel on the skateboard. What happens if he throws me off of it? Ow! Then I fall off and Joel moves forward. A rocket works just like this, but instead of children, a rocket pushes out from a lot of gas. You see it here as big clouds. The gas thrusts downward and the rocket is pushed upward. The physicist Isaac Newton came up with this trick. He discovered that for every action, there's an equal and opposite reaction. Sounds complicated? Not really. Actually, you can use it in cool experiments. Experiment 2. Get a bucket, make 2 holes in it. Fasten 2 tubes into the holes and hold the bucket. What happens to the bucket when I fill it with water? The water pours out and the bucket starts spinning. According to Mr. Newton, water flowing out of one side is the action, and the reaction is that the bucket spins in the opposite direction. Action, opposite, reaction. Rockets use the same trick. In this building, Ariane rockets are assembled. An Ariane rocket consists of a big engine and 2 boosters on the side. The cargo that must get into space is in the top of the rocket. Time to build our own rocket. Experiment 3. You can make the simplest rocket from a piece of paper. Roll the paper to form a cylinder. Paste one end shut and make some cool fins along the side. Slide the rocket over a straw. If you blow through the straw, the air comes out of the bottom of the rocket. This is the action. The opposite reaction is that the rocket takes off. But of course, a rocket really launches from a launch pad. Wow! What a big place! Rockets lift off from here. Destination, space. Now it's time for my little rocket. There it goes. 3, 2, 1. See, my rocket doesn't get very far. Maybe Joel can blow harder. Okay, it got a little bit higher. But if you really want to send it soaring, you have to make a stomp launching device with an airbed pump. Wow! Now it really flies. I can't even see it anymore. Three, two, one, liftoff! The rocket engines are much more powerful. Very hot gas releases under the rocket. This is the action. The opposite reaction is that the rocket is pushed upward. Wow! The rocket weighs 780,000 kilograms. That's why it has 2 extra engines to help the main engine, the boosters. When there's no more gas left in the boosters, they disconnect from the rocket. At the height of 170 kilometers, the main engine is also empty, and it disconnects. These engines are huge and powerful. They are necessary to help the rocket lift off and gain speed quickly. Now that the rocket is high enough, it can continue with a smaller engine. The engines are called stages, so the Ariane rocket is called a 3-stage launcher. A balloon works just like a rocket engine. If you attach it with a straw on a string, 3, 2, 1, there it goes. The air comes out from the back end and the balloon propels forward. Can you make a 2-stage rocket from a balloon? Blow up a balloon and secure the opening of the second balloon to it with a rubber band. Now you have 2 engines. Attach it again to the line. 3, 2, 1. When the red balloon is empty, the rubber band loosens and the air jets out of the green balloon. This way, it gets even further. Experiment 5. I have a light beach ball and a heavy bowling ball. Joel stands on the skateboard and throws the balls. That is the action. Which ball has the biggest opposite reaction? First, the light beach ball. Throw it as hard as you can. Nice. But he hardly moves. This means there's no opposite reaction. And now the heavy bowling ball. Yeah, now Joel moves a bit. Conclusion, the heavier the ball, the bigger the action. And the bigger the action, the greater the opposite reaction. A rocket that uses air is cool, but isn't it better to use something a bit heavier than air? For example, water. Time for the 6th experiment. Take a plastic bottle. This is the rocket. Fill the rocket 1/3 with water. Drill a hole in a cork and insert a bicycle tire valve. Plug the cork into the opening of the plastic bottle and place the bottle on your homemade launch pad. Now comes the dangerous part. Don't lean over the rocket and don't stand too close. Attach a bicycle pump and slowly begin to pump. The water in the bottle builds up pressure. When the pressure reaches a maximum, the cork blasts out and the water also spurts out. Wow, that really flies. A squid makes use of the same trick. If it wants to move quickly, then it forces a jet of water through its body and spits it out to propel it forward. If you throw a beach ball while standing on a skateboard, you won't move. Air is light, so the opposite reaction is minimal. Rockets use hot gas to get into the air, which is also light, and yet they still manage to ascend quickly. How do they do that? I set a hairdryer to its lowest speed. Hot air comes out. When I put it on a skateboard, it rolls slowly forward, but it doesn't get very far. Now, when I set the hairdryer on the highest speed, the air rushes out quickly. And look, the skateboard moves more quickly. The action is bigger, so the opposite reaction is also bigger. Fireworks are the most like rockets. There is also fuel in the firework rocket. If you light it, it forms a lot of gas. That gas can only escape out of the bottom of the rocket, so the rocket lifts upward. When the rocket is in the air, it explodes. There are many small burning pieces that form and blow out in all directions. That's how we get such beautiful patterns in the sky. My rocket will never get to space. It's simply not strong enough, unfortunately. But could I get to school with a rocket engine? Yeah, I could, but it isn't very smart. That's why I let my friend Joel do it. Ready? 3, 2, 1. The gas in the fire extinguisher is also under pressure. When you pull the plug and let it out, you get an opposite reaction. Joel cruises forward. Wow!